So how come a triangle makes 180 degrees? The proof is a little bit past what we can do at this point, but I'm going to try and show you, at least demonstrate to you, that it is in fact true. This doesn't look like a triangle, but it actually is. It's just, it's kind of, I don't know. Anyways, so with this, I'm going to take, I just colored each of the corners so that way we can kind of keep track of them. If I'm going to rip off like each of the corners, okay, to see, well, how big are all these angles on a triangle? Like, they should add up to 180 degrees. So if I rip them off one at a time here, and then I put them all together, I'm like adding them all up. And if I put them all together, every single time, it's going to make a straight angle. Maybe you can see it like that way. But it'll make a straight angle. And then some of you guys are like, well, is that true for every single triangle? And I'm going to say, yes, it is true for every single triangle. And you have no friends. Those of you that asked that. No, I'm just kidding. But sort of. Anyways, so on this one, if I do the same thing, so I have a different kind of a triangle here, and I can rip off all the corners and put them all together. And if I put all those ones together, looky there, I have another 180 degree angle. So I've kind of just shown you that on triangles, all the angles added up together are going to be 180 degrees. Did I prove it? Not exactly, but at least like you can now like visualize it. Anyways, so let's talk about, or check out. I don't know. I'm checking out. So let's talk about 3.6 types of triangles that we have. This section is actually going to go pretty quick for you. So we have scalene triangles. Scalene is where no two sides are congruent to each other. So maybe I want to have like there we go. So this side is not the same as this side, is not the same as this side. So that would be a scalene triangle. And isosceles triangle. Now, usually when I'm thinking of isosceles triangle, I'm thinking of that two sides are congruent to each other. Technically, the definition for an isosceles triangle is at least two sides are congruent. So really, an equilateral triangle also is an isosceles triangle. Kind of interesting. So on an isosceles triangle, the two sides that are congruent to each other, they're called the legs. And the angles that are that kind of form the bottom side, that's called the base. It's not always the bottom, but it's the two sides that are not you have the legs are the two sides that are congruent, and the base is the other side that's not necessarily congruent to the legs. And then you also have your like lower base angles, so these would be called like your lower base angles. I don't remember if you need to know that for this section, but at some point you'll need to know that. And then like on this other picture, these two would be the legs on this isosceles triangle, and this part would be the base. I'm all about that base, Equilateral triangle is where all of the sides are congruent. So like I said, technically at least two sides are congruent to each other, so all equilateral triangles are also isosceles triangles, but not all isosceles triangles are equilateral triangles. So all the sides are congruent, and really, you can also have what's called an equiangular triangle, where all the angles are congruent. Well, really, if all the sides are congruent to each other, you're also going to have all the angles are congruent to each other. How many degrees are all the angles on an equilateral, or on an equiangular triangle, which is also an equilateral triangle? Since all the angles add up to 180 degrees for all triangles, 180 divided by 3 equal ones, they'd each be 60 degrees on an equilateral triangle, also known as an equiangular triangle. Acute triangles is where all the angles are less than 90 degrees but bigger than 0 degrees. A right triangle has exactly one right angle. Can any triangle have two right angles? No, it can't, because if a triangle has to add up to 180 degrees and two angles are right angles, you're already at 180 degrees. There's nothing left. There's nothing left for the third angle. Besides, try imagine drawing that. Okay, here's one right angle, and then here's the other right angle. Oh wait, those two lines are never going to hit each other. How am I supposed to make a triangle out of that? You can't. So a right triangle, one of the angles is a right angle. So these two sides are called the legs that make up the right angle. And then the side that's opposite the right angle is called the hypotenuse. Hypotenuse. So hypotenuse on this one would be right there, opposite the right angle. And these two would be the legs. Corny joke coming. get ready, brace yourself. So what did the hypotenuse say to the other two sides of the triangle? Said nice legs. Ha ha. You're laughing. Don't lie. You're laughing right now. Even though I can't see you, I know you're laughing. An obtuse triangle is where one angle is obtuse. Is it possible for a triangle to have more than one obtuse angle? No, because again, it would be greater than 180 degrees, and you would run into the exact same problem that we had up here. Imagine drawing like two obtuse angles. There's no way those are going to connect. That won't create a triangle. The sum of the angles of a triangle is 180 degrees every swinging time. So if the perimeter of a triangle is 50, determine what kind of triangle it is. So perimeter means like all the outsides put together. So if I add up all these pieces and set them to 180, no, okay, they're not all the angles. If I was saying, hey, all of these angles, this angle was 3x, this angle was the 5x minus 5, this one was the 2x plus 5, then add up all the angles and set them to 180. But not all the sides. Sides are distances, not degrees, distances. All the sides added up together come up with the perimeter. So that perimeter would be 50. So my 5's would drop off. 2x and 3x makes 5x plus another 5x is 10x. Equals 50, divide by 10s, x is equal to 5. They want to know what kind of triangle this is. So as of right now, the best I can call this triangle is a scalene triangle. If I plug 5 in here, I've got 3 times 5, that would make this side 15. If I plug 5 into this one, 2 times 5 plus 5, 10 plus 5 would be 15. So now it's bumped up from being a scalene triangle to now it's at least an isosceles triangle. Maybe it will be equilateral, but I know for sure at least it's isosceles. Whenever it says determine what kind of triangle it is, like even though equilateral triangles are also isosceles triangles, give it the most specific name that you can, okay? So I'm going to check to see, could I possibly call this an equilateral triangle? So 5 times 5 minus 5 for last side, 25 minus 5. No, it is not an equilateral triangle. Only 2 of the sides are congruent. Best thing I can call it is an isosceles triangle. And we have a proof. Yes, I do want you to write this one down. This is kind of awkward. Like I'm sitting here in this class all by myself and I'm teaching. I hope the janitor doesn't walk in. I think I'm nuts. Okay, so knowing that K and L trisect JM, I'm probably just going to put, maybe I don't need it, but I'm going to just put down that all 3 of those have to be congruent to each other. At least then I got it. JK congruent to KL congruent to LM. Trisect makes 3 congruent segments. Maybe I'll put down those other givens, or there's only one more. JKI congruent to angle MLI. JKI, that's this one. MLI, that's this. Hey, I've already got 2 congruent triangles. I didn't even really have to work for it other than the trisect. So I'm going to go ahead and say those 2 triangles are congruent. Triangle JKI, JKI, go in the same order for the second triangle. MLI. I've got a side, included angle, and a side. Now that I've got congruent triangles, let me see what the heck it was I was going for this whole time. I'm trying to prove that I have an isosceles triangle. That the big triangle, triangle IJM, this guy has to be an isosceles triangle. And all I have are the top triangle and the bottom triangle are congruent. So try and think of what CPCTC, oh, there's that word again, we keep using it a lot. What CPCTC should I use to help me show that that big triangle is an equilateral triangle? Or not an equilateral, isosceles triangle. Well, I need to have two sides congruent on an isosceles triangle, or on a triangle, to show that it's an isosceles triangle. So what if I said side JI was congruent to side IM by CPCTC? Let's do it. JIIM, congruent. CPCTC. So with that out of the way, I think we can go and just say that, hey, this is an isosceles triangle. Triangle IJM is an isosceles triangle. What reason is that? Guess we better add one to our list. You could write like isosceles triangle has two congruent segments. You can write definition of isosceles triangle. I don't care. Maybe we'll go back to this and add this to your list. Isosceles triangle, at least two sides are congruent. If you just want to write for shorthand, definition of isosceles triangle, that's good enough for me, okay? I know that by now you've learned isosceles triangle since like the 2nd grade. You knew what it was, so I'm okay you just writing definition of isosceles triangle. Because of the definition of isosceles triangle, or because I have at least two sides congruent. Cool. So that's it for now. Pretty easy section here, which is nice, a nice breather after that 3.5. So this is Mrs. Rainey, and I am signing off.